the pioneering project of Seumeren, and the revolutionary PTC crane. Inception of the PTC crane. In January 1999, the team at Seumeren was immersed in the construction of what was set to become a revolutionary piece of equipment in the heavy lifting and transport industry. The Platform 2 Green Container, PTC crane. This ambitious project was a testament to Seumeren's commitment to innovation and their collaboration with Huisman, a company renowned for its expertise in designing and manufacturing heavy construction equipment. The design phase of the PTC crane was an intricate process that spanned several months. Engineers and designers from both Seumeren Innovation and Huisman worked tirelessly to bring this concept to life. The idea was to create a crane that not only had immense lifting capacity, but was also versatile and easily transportable. This led to the unique decision to design the crane's components to fit within the dimensions of standard 20 or 40-foot containers. The benefit of this design choice was clear. It allowed for the entire crane to be transported via standard shipping methods, including road, water, and rail, making it an integrated solution for global logistics. Early challenges and testing. The initial assembly and testing of the PTC crane took place at a designated harbor site. This location was chosen for its expansive area and proximity to essential logistics routes. The timeline for this phase was tight, with only 2 weeks allocated for assembly, testing, and certification. The urgency was driven by the crane's first scheduled job in March of the same year, at a Royal Dutch Shell refinery construction site in Canada. The stakes were high, and the team knew that any delays could jeopardize their reputation and the project's success. The assembly process was a meticulous endeavor. Each containerized component had to be precisely positioned and secured. This task was well within the capabilities of Seumeren's experienced crew, who had previously handled heavy cranes of similar complexity. However, the PTC crane presented new challenges with its innovative design and the requirement for absolute precision in assembly to ensure optimal performance and safety. A critical aspect of this phase was the presence of experts from Lloyd's, the renowned insurance company. Their role was to oversee the assembly and certification process, ensuring that every step adhered to the highest standards of safety and reliability. This added an extra layer of pressure, but also underscored the importance of rigorous standards in the engineering and construction industries. The first significant test for the crane came with the tensioning of the steel cable. Measuring 1.5 kilometers in length and over 5 centimeters in thickness, this cable was a critical component of the crane's lifting mechanism. The tensioning process required precise calibration to ensure the cable could handle the immense loads it would be subjected to during operation. This process often took place at night, adding to the intense atmosphere and the sense of urgency. After 9 days of relentless work, the crane stood tall in its full glory. The next step was to conduct the first real test, lifting a pontoon filled with water weighing a staggering 1,500 tons. This test was crucial, not only for demonstrating the crane's capabilities, but also for identifying any potential issues that needed to be addressed before the crane could be deployed in a real-world scenario. Innovations and technical advances. One of the standout features of the PTC crane was its superlift. In heavy lifting operations, the counterweight is a major factor in the crane's overall weight and stability. Traditionally, cranes required massive counterweights to balance the loads they lifted, which posed significant logistical challenges and costs. The superlift system of the PTC crane was designed to address this issue by maximizing the radius to 22 meters and shifting the pressure point backward. This innovative approach reduced the required counterweight by 500 tons compared to conventional systems, significantly cutting down transportation costs and improving operational efficiency. Meanwhile, another team at Seumeren was engaged in a different but equally complex task. At Huisman's facility, they were preparing for the loadout of a large component for a pipelaying vessel. This apparatus, measuring 132 meters in length and 14 meters in width, and weighing 2,200 tons, was designed for laying pipelines at great depths underwater. The client needed this component shipped to the Wilton Feyenoord shipyard as soon as possible. The loadout process involved the use of self-propelled modular transporters, SPMTs, which are specialized vehicles capable of carrying extremely heavy loads. These vehicles can handle up to 30 tons per axle, ensuring that even the heaviest structures can be transported safely and efficiently. The SPMT's modular design allows them to be configured to carry loads of various sizes and shapes, making them an ideal solution for transporting the massive pipelaying component. Global logistics and operations. While the testing of the PTC crane continued, the focus also shifted to its logistics. The crane was scheduled to be shipped to Canada, and the logistics team had to ensure that every detail was meticulously planned. The PTC crane was to be transported on the Bon Express, a ship that maintained a regular service between Canada and the United States. This vessel was chosen for its capacity and reliability, ensuring that the crane would be delivered on time. The loading process was a complex operation in itself. The project leader from Seumeren was present to oversee the loading, ensuring that every container was securely placed and balanced. The team worked closely with the ship's crew to coordinate the loading sequence, taking into account the weight distribution and the order in which the containers would be needed at the destination. Upon arrival in Halifax, the largest port on Canada's eastern coast, the unloading process began immediately. 2 harbor cranes were used to swiftly extract the necessary containers from the ship. The containers were then transported by train across a vast, snow-covered landscape to the construction site, a journey spanning 5,000 kilometers. This journey was closely monitored by Seumeren logistics team and personnel from Canadian National Railways, ensuring that the containers arrived safely and on schedule. Diverse projects and challenges. In addition to the PTC crane project, Seumeren was involved in several other significant operations. In Groningen, the company was tasked with clearing an old gas factory site due to severe soil contamination. The local council wanted to preserve 2 historical storage sheds by relocating them to make way for new developments. This delicate task was handled by Seumeren's jacking service department, which lifted the sheds onto platform vehicles for safe transport. The operation was conducted under media scrutiny, highlighting the importance of preserving historical structures while addressing environmental concerns. Meanwhile, in Hardingsveld-Giessendam, another team was preparing for a dredging project in Austria. This involved transporting pontoons and other heavy equipment to the remote site. The convoy, including Europe's heaviest mobile crane, had to navigate challenging conditions, including steep and icy roads. The journey required meticulous planning and coordination to ensure the safety and efficiency of the transport. In Canada, Mammoet, a major heavy transport company and a partner of Seumeren, was engaged in transporting large components for Shell's new refinery. This operation involved navigating frozen roads and raising power lines along the route to accommodate the height of the components. The convoy, supported by a team of technicians, moved through the night to minimize disruptions to local communities. Despite the harsh conditions, the journey was completed in 4 days, demonstrating the team's expertise and resilience. Complex international operations. Mamoué was also involved in another complex international operation, transporting high-pressure vessels from Japan to the interior of Europe. These vessels, used in various industrial applications, required specialized handling due to their size and weight. The journey began with ocean transport to Europe, followed by the use of inland waterways. However, low water levels presented a significant challenge, causing delays. The vessels were eventually unloaded in Bratislava using a specialized crane system designed for handling such massive loads. Throughout these projects, Van Seumeren and Mamoué demonstrated their expertise in handling complex heavy lift and transport operations. Their innovative solutions and technical prowess were evident in every aspect of their work, from the design and assembly of the PTC crane to the intricate logistics of international transport. The successful completion of these projects underscored their position as leaders in the heavy lifting and transport industry. The Van Seumeren legacy and future innovations. The story of Van Seumeren and the PTC crane is a testament to the power of innovation and collaboration in the engineering and construction industries. The PTC crane represented a significant leap forward in crane design, combining immense lifting capacity with unprecedented transportability. This achievement was made possible by the dedicated efforts of engineers, designers, and logistics experts who worked tirelessly to bring this vision to life. The success of the PTC crane project also highlighted the importance of meticulous planning and execution in large-scale engineering projects. Every detail from the initial design to the final assembly and testing was carefully considered to ensure the highest standards of safety and performance. The presence of Lloyd's experts during the certification process underscored the commitment to quality and reliability that is at the heart of Van Seumeren's operations. Looking to the future, Van Seumeren continues to push the boundaries of what is possible in the heavy lifting and transport industry. Their ongoing commitment to innovation is evident in their continued development of new technologies and solutions designed to meet the evolving needs of their clients. As the industry faces new challenges, from increasing load capacities to the demands of global logistics, Van Seumeren is well positioned to lead the way with their expertise and vision. In conclusion, the story of the PTC crane and the various projects undertaken by Van Seumeren and Mammoet is a testament to the power of innovation, collaboration, and meticulous planning in the engineering and construction industries. Their achievements demonstrate the potential for transformative The Platform 2 Green Container, PTC crane, a revolutionary innovation by Van Seumeren in collaboration with Wiseman, has been pivotal in numerous high-profile projects around the world since its inception in January 1999. This crane, renowned for its incredible lifting capacity and transportability, has been instrumental in shaping infrastructure, energy, and industrial projects. Here, we explore in detail some of the key projects that showcase the versatility and efficiency of the PTC crane. 1. Royal Dutch Shell Refinery, Canada. The PTC crane's first major assignment was at the Royal Dutch Shell Refinery construction site in Canada. This project was critical for Shell as it marked a significant expansion in their refining capabilities. The crane's modular design, which allowed it to be transported in standard shipping containers, was a perfect fit for the remote Canadian site. The assembly of the crane on-site was a testament to its innovative design, allowing it to be operational within days. The PTC crane lifted massive refinery components, including distillation columns and reactors, some weighing up to 1,500 tons. Its precision and lifting capacity ensured that these components were installed with exacting accuracy, minimizing delays and maximizing efficiency. 2. Offshore oil platform construction, Gulf of Mexico. In the Gulf of Mexico, the PTC crane played a crucial role in the construction of an offshore oil platform. This project required lifting and placing enormous structural sections of the platform. The PTC crane's superlift system, which reduces the need for massive counterweights, was particularly advantageous in the constrained space of an offshore platform. Over several months, the crane lifted deck modules, drilling rigs, and accommodation blocks, each weighing hundreds of tons, and positioned them with remarkable precision. The crane's ability to operate in challenging offshore conditions demonstrated its robustness and reliability. Three. A nuclear power plant, France. The PTC crane was deployed at a nuclear power plant construction site in France, where it was used to handle extremely heavy and sensitive components. The installation of reactor vessels, steam generators, and cooling towers required the highest standards of safety and precision. The crane's advanced control systems and fail-safe mechanisms were crucial in ensuring the safe handling of these components. Additionally, its modular design facilitated transportation and assembly on-site, a critical factor given the stringent security and logistical constraints of a nuclear facility. The PTC crane's performance in this high-stakes environment underscored its capability to handle the most demanding projects. Four. Bridge construction, Norway. In Norway, the PTC crane was integral to the construction of a major suspension bridge. The bridge, spanning a fjord, required the installation of massive steel sections and cable systems. The crane's reach and lifting capacity were essential in positioning these elements accurately over the water. The project also benefited from the crane's ability to operate in harsh weather conditions, a common challenge in Norway's coastal regions. The PTC crane lifted and positioned tower sections, main cables, and deck segments, enabling the project to progress smoothly and on schedule. This project highlighted the crane's adaptability and strength in civil engineering applications. Five. Offshore wind farm, North Sea. The renewable energy sector also saw the PTC crane in action, particularly in the construction of an offshore wind farm in the North Sea. The crane was tasked with installing wind turbine components, including monopiles, transition pieces, and nacelles. Each turbine required precise placement of these components to ensure optimal performance. The PTC crane's advanced control systems allowed for the fine adjustments necessary to achieve this precision. Its ability to lift heavy loads in challenging offshore conditions was a key factor in the project's success, contributing to the growth of renewable energy infrastructure. Six. High-rise building construction, Dubai. In Dubai, the PTC crane was involved in the construction of a new high-rise building, part of the city's ever-expanding skyline. This project required lifting and positioning prefabricated sections of the building's superstructure. The crane's height and lifting capacity were crucial in handling these large components. Working in a bustling urban environment, the crane's precision and efficiency minimized disruptions and ensured the safety of the surrounding areas. The project demonstrated the PTC crane's suitability for complex urban construction, where space and timing constraints are significant. Seven. Petrochemical plant, Saudi Arabia. The construction of a petrochemical plant in Saudi Arabia was another significant project for the PTC crane. The plant required the installation of large distillation columns, reactors, and storage tanks. The crane's ability to lift and place these heavy components with precision was essential for the project's success. The harsh desert environment posed additional challenges, but the crane's robust design and reliable performance ensured that it could operate effectively under these conditions. The project's scale and complexity highlighted the crane's versatility and capability in the industrial sector. Eight. Shipyard operations South Korea. In South Korea, the PTC crane was deployed in a major shipyard to assist in the construction of large vessels. The shipbuilding process involved lifting and positioning massive hull sections, superstructures, and engines. The crane's capacity to handle these immense loads with precision was critical to maintaining the shipyard's production schedule. Its modular design allowed for easy relocation within the shipyard, providing flexibility in handling different stages of ship construction. This project showcased the crane's utility in the maritime industry, where heavy lifting and precision are paramount. Nine. Power plant installation India. In India, the PTC crane was instrumental in the installation of a new thermal power plant. The project involved lifting and positioning boiler units, turbines, and cooling towers. The crane's lifting capacity and reach were crucial in handling these large and heavy components. Additionally, the crane's ability to operate in the tight confines of the power plant site ensured that the installation process was efficient and safe. The PTC crane's performance in this project underscored its suitability for large-scale energy infrastructure projects. Ten. Infrastructure development. China. China's rapid infrastructure development has seen the PTC crane involved in multiple projects, including the construction of a major railway bridge. This project required the installation of long steel girders and bridge segments. The crane's lifting capacity and precision were essential in ensuring that these components were placed accurately, allowing for the seamless construction of the bridge. The project's scale and complexity demonstrated the crane's ability to handle large infrastructure projects in rapidly developing regions. Eleven. Modular refinery Nigeria. In Nigeria, the PTC crane was used in the construction of a modular refinery. This project involved the installation of prefabricated modules, including processing units and storage tanks. The crane's modular design and lifting capacity were key factors in handling these large components. The project highlighted the crane's ability to operate in remote and challenging environments, providing a flexible and efficient solution for complex industrial projects. Twelve. LNG Terminal Australia. The construction of an LNG, liquefied natural gas terminal in Australia, was another significant project for the PTC crane. The terminal required the installation of large storage tanks, loading arms, and processing equipment. The crane's lifting capacity and precision were crucial in handling these components, ensuring that they were installed safely and accurately. The project's scale and the high safety standards required in the LNG industry underscored the crane's capability to handle complex and demanding projects. 13. Historical Monument Restoration, Italy. In Italy, the PTC crane was involved in the restoration of a historical monument. This project required the delicate lifting and placement of large stone blocks and architectural elements. The crane's precision and advanced control systems were essential in ensuring that these components were handled with care, preserving the integrity of the monument. The project demonstrated the crane's versatility and capability in handling not only heavy industrial components, but also delicate historical elements. (14) Space Launch Facility, United States. In the United States, the PTC crane played a role in the construction of a space launch facility. This project involved lifting and positioning large rocket components, launch towers, and support structures. The crane's lifting capacity and precision were crucial in handling these components, ensuring that they were installed accurately and safely. The project's complexity and the high standards required in the aerospace industry highlighted the crane's advanced capabilities and reliability. (15) Industrial Plant, Germany. In Germany, the PTC crane was used in the construction of an industrial plant. This project involved lifting and installing large machinery, including presses, furnaces, and assembly lines. The crane's lifting capacity and precision were essential in handling these heavy and complex components. The project's scale and the need for precise installation demonstrated the crane's capability to handle large industrial projects efficiently and safely. (16) Arctic Research Station, Greenland. The construction of an Arctic research station in Greenland presented unique challenges for the PTC crane. This project required lifting and positioning prefabricated modules and scientific equipment in extreme cold conditions. The crane's robust design and ability to operate in harsh environments were crucial for the project's success. The crane's modular design also facilitated its transport and assembly in the remote Arctic location, underscoring its versatility and reliability. (17) Hydroelectric Dam, Brazil. In Brazil, the PTC crane was instrumental in the construction of a hydroelectric dam. This project required the lifting and installation of large concrete segments, turbines, and generators. The crane's lifting capacity and precision were crucial in handling these heavy components, ensuring that they were installed accurately and safely. The project's scale and complexity demonstrated the crane's capability to handle large infrastructure projects efficiently. (18) Stadium Construction, Qatar. In Qatar, the PTC crane played a key role in the construction of a new stadium for the FIFA World Cup. This project involved lifting and positioning large steel roof sections and structural components. The crane's lifting capacity and precision were essential in handling these components, ensuring that they were installed accurately and safely. The project's scale and the tight construction schedule underscored the crane's capability to handle large,